What is up, YouTube? We got a banger video today. It is about relative motion, and it is question 8 on the F equals MA 2026 exam. This one's pretty cool. Let's just get straight into it, all right? We got a puck with mass little m, moves the speed v towards a heavy bump of mass big M, where big M is much bigger than small m. Get it? Because, okay, both the puck and the bump slide without friction, and the bump moves towards the puck with a speed v/2 and provides smooth transition from the horizontal surface onto the bump. The bump is tall enough that the puck slides back down. So find the maximum height that the puck reaches. All right, guys. So when we look at a question like this, you got to understand what's going on first. So we got this puck moving up this bump, gets to some certain height and falls back down. And this height is h max. Very cool. Also, we got to look at the answer choices. All right, I'm looking at the answer choices. It's a little blurry, but I hope you guys can see that all of them have v squared. Oh my goodness. This is already just screaming to you that it's going to be kinetic energy. All right, but now obviously we know the maximum height that something will reach if it's just all kinetic energy is converted to potential energy, right? That's answer A. And we know that probably isn't right because this bump is also moving. So we can already immediately eliminate that. A good way to look at this is to then take the reference frame of the bump and then calculate the kinetic energy of the puck and then just see how high it reaches from that. So let's do that. What is the velocity of this bump? The velocity of big M will just be equal to negative v/2. What is the velocity of the puck? The velocity of little m will just be equal to v. So the velocity of little m relative to big M will then be equal to the velocity of big M, which is negative v/2, minus the velocity of little m, which is just going to be v. So then we got negative 3v/2. So if we want to calculate the kinetic energy of little m, which is ultimately what we want to do, we can say kinetic energy of little m in the reference frame of big M will be equal to 1/2 little m, where its v now is negative 3v/2. We square that. So then we get that this is equal to negative 9. Well, not negative because we squared. So that's 9 divided by 4 v squared times m. All right, and this is equal to m. And okay, so this is our kinetic energy, right? And we know at the very end of this bad boy, when it's at its highest, when it's at its h max, we have the kinetic energy will be equal to the gravitational potential energy, which will be equal to mass times the gravity times h max. So we can equate these equations together, and we got 9/4 v squared times m is going to be equal to this bad boy. We can cancel out m, and then divide both sides by g. And guess what we get? We get that the h max is equal to 9/4 v squared divided by g. Shaboom. And guess what answer that choice that is? Yeah, that's right. Answer choice B. And yeah, great job, guys. This is how you do it. Relative motion. So we got relative motion. You switch to the reference frame of this big bump, and then after you do that, you just calculate the kinetic energy of this little guy relative to the bump, and you're able to find its maximum height from that. And a good little teaser for you guys before I sign off is can you see why switching to the puck's reference frame